So now note that of ax dx is not equal to integral of ax times integral of bx dx. So these two are not equal, all right? And we'll see a lot of techniques for integration, which will basically help us out on how to integrate when your function looks like multiplication of two functions or rather product of two functions. So here you have minus 2x multiplied by e to the minus x squared, and you want to integrate it. Okay. So here in this case, if you let u equals to e to the minus x squared, then you will get du by dx is going to be e to the minus x squared times derivative of minus x squared, which is minus 2x. So therefore, you can see that this implies that du is same as e to the minus x squared times minus 2x dx. So this differential du is equal to this differential. So if you integrate this, you can see that integral of this guy, which is on the right hand side, integral of this is going to be integral of du. So this integral is going to be u. So u plus c is integral of e to the minus x squared times minus 2x dx. So if you compare, what was your u? Your u was e to the minus x squared plus c, and that is your integral of minus x squared. So the integral of this guy is equal to this, all right? So such a method is called substitution rule, okay? So you're substituting, but when you substitute, you notice that the derivative of minus, so when you substitute e to the minus x squared, you notice that derivative of e to the minus x squared, which is e to the minus x squared times minus 2, is already there, okay? Now there could have been one more substitution which could have worked out in this scenario. You could have let u equals to minus x squared. Okay, so this is another way of doing the same problem, right? I mean, it's the same way, but the substitution is different. So in this case, if you let u equals to minus x squared, what do we get is we get du. So if we let u equals to minus x squared, you get du e by dx is minus 2x, or we get du equals to minus 2x dx. So now you can replace your original integral by, so e to the power, instead of minus x squared, I'm going to replace everything now in terms of u. So this will become e to the power u, and minus 2x dx, that is what the remaining part is here. I'll replace that with what? Du. And when I integrate this, I get e to the power u plus c. And then I'll resubstitute back what was my u. My u was minus x squared. So you see, I'm getting the same integral in both the cases, which should not be surprising. Yeah. So such a method is called substitution rule, right? So let's see, when do we decide to use substitution rule? So substitution rule is an outcome of the following. Suppose you have u as a function, differentiable function of x, u equals to g of x, whose range is interval I. So the function range is interval I, and f should be defined on the interval I. So this is to say that f of g makes sense. So if you're given f of g of x times g prime dx is same as integral of f of u du, right? So it looks like these two are going to be exactly the same thing, okay? So now this can be proved using chain rule of differentiation. So how can you prove it using chain rule of differentiation? You have the following. So let's look at this. So you have d by, so we can say f of g of x. Yeah. So let's look at f of g of x. And if you take derivative of this, what do you get? You get f prime g of x times g prime of x. Yeah. So this is one way of looking at it. So now, therefore, integral of f prime g of x times g prime dx is going to be integral of f of g of x. What? So you have, in this case, we had f prime. Now replace this f prime by another function f. In that case, you will have, so let me replace this by, so this is the chain rule. So let me replace this by capital F. So if I replace this by capital F, then this is going to be capital F. This is going to be capital F. And that is going to be, and that is same as, actually, that is going to be same as integral of what? Derivative of this guy with respect to u du, where your g of x equals to u. Okay. So this is how the game is played. All right. So now let's do a problem based on this. So here we want to do this integration, indefinite integral, using substitution rule. So what shall we substitute? So you can see that x cubed plus 5, so the derivative of x cubed plus 5, which is 3x squared, is lying there, right, next to it. So therefore, we'll try. So let's try u equals to x cubed plus 5. So this is a substitution. Now, when you do the substitution, you have to replace all the variables now in terms of u. So what do I get from here? I get du by dx equals to 3x squared. This would mean du equals to 3x squared dx. Or I can say du by 3 equals to x squared dx. So now this integral can be replaced by integral. Instead of x cubed plus 5, I'm going to write u. So u to the power 9. And instead of x squared dx, I'm going to write du by 3. So this is going to be 1 by 3 integral of u to the power 9, which is going to be u to the power 10 by 10 plus c. Now, this is a temporary substitution. We re-substitute back what your u is, which is going to be x cubed plus 5 to the power 10 plus c. So this is your integral. Does that make sense? Let's look at this problem now. So how would we go about it? In this case, we should let 3 minus 5t equals to u. Yep. So what do we get out of this? So this implies minus 5 equals to du by dt, or dt equals to du over minus 5. So then the integral turns out to be, the integral I is, let's call this I. So the integral I is going to be, instead of dt, I'm going to write du over minus 5. And instead of square root of 3 minus 5t, I'm going to write square root of. So this can be written as take minus 1 by 5 out integral of u to the power minus half du, and that is going to be using the power rule, u to the power half plus 1, which is u to the power half, dividing by half, which is same as multiplying by 2. So we get minus 2 by 5, u to the power half. What was your u? Your u is 3 minus 5t. Power half is taking square root plus c. Right? Now note that here you simplified the denominator, and then so that you can basically take the derivative. Sorry, take the integral. Now what about this guy? Integral of sine 3t dt. In this case, let u be equal to 3t. So this implies what? This implies sine. So this implies du equals to 3 dt. And then when I write the integral, instead of dt, I'm going to write du by 3, right? So I'll write sine of u times du by 3. Now integral of sine is what? Minus cosine. So minus cosine u by 3 plus c, which is going to be minus cosine of 3t by 3 plus c. Okay. In fact, there are some rules you can write directly. So for example, this will be a good thing to prove. Integral of ax plus b to the power n dx is going to be, it's almost like a power rule. So you have same thing divided by n plus 1 plus c. The extra part is you have to divide by the coefficient of a. Again, this note that this is only valid for the linear function to the power n. If n is not minus 1, and if n is minus 1, you will get ln of absolute value of ax plus b divided by a if n equals to minus 1. So same rules can be extended in the following way. And again, I think it's a good idea to prove them before you use it. You can prove them using substitution rule. So you get same thing. You have sine ax plus b to the dx, sine ax plus b dx is going to be same as, so integral of sine is minus cosine. So minus cosine of ax plus b, you divide by a plus c. Okay. So similarly, there are other rules you can basically prove. Let's move ahead now and do the next problem. So in this case, we see that derivative of ln u is 1 over u, which is next here. So let ln u equals to x. So in this case, we are replacing the substitution. In substitution, we are replacing it by a new variable x, right? So this implies dx by du. So we want to write everything in terms of x now. So dx by du is going to be derivative of ln u with respect to u, which is 1 over u, not 1 over x. Or this implies dx equals to du over u. Yeah. Why did I choose that? Because I need to replace this guy now. Okay. So in that case, the integral becomes, so let me call this integral I. So my I becomes integral of, instead of u, 1 by u, I have dx. And in the bottom, instead of ln u, I have x squared. And this is same as x to the power minus 2 dx. Integral of that is x to the power minus 1 over minus 1 plus c. Or it can be also written as 1 over x plus c. You resubstitute back what your x is. So you get 1 upon ln u plus c. Let's look at the next one now. In this case, observe that derivative of pi by v is minus, so derivative of 1 by v with respect to v, of course, is minus 1 by v square. And that is there, right? So 1 by v square is here. So what we'll do is let pi by v equals to u. So u is the new variable we want to substitute everything into. So we get du by dv equals to minus pi by v square. This implies du by minus pi equals to dv by v square, because after all we want to replace this guy, right? We already found out replacement for pi by v. We want to replace this part. So what do we get? So the integral, let me call this as I. So I becomes integral of sine u times du by minus pi. So I'm going to write over minus pi. Now minus 1 by pi can come out. It's a constant. Now integral of sine u is minus cosine u plus c. So this minus and the minus will cancel out each other. So you will have cos of divided by pi plus c. But instead of u, we can put back what u was. It is pi over. Okay, so this is how this works. Now let's look at the following problem. So square root of 1 minus z square upon square root of 1 minus z dz. Now note that here the denominator is not simple, right? It's square root of 1 minus z, for which we don't have any formula. So let's see what we'll do here in this case is take 1 minus z equals to u. So you will get minus dz equals to du, or du equals to, or dz equals to minus du. So in this case, you will see that then what is my z? My z is 1 minus u is z, right? So this integral is then 1 minus u square divided by square root of u, and instead of dz I'm going to write du, but with a minus sign, which I'll keep outside. Now let's expand this out. So we get minus 1 by square root of u. So the top simplifies as what? You have 1 minus u the whole square. So you have a minus b the whole square, which is going to be a square plus b square minus 2ab du. Now you'll say, well, what was the point of doing this? Now note that since the denominator has simplified, you can distribute it over and you can integrate. But earlier there was not really a direct chance of integrating, right? So this is the advantage of doing this. So we get minus of u to the power. So now u will divide to square root of u will go below each one of them. So this is going to be u to the power half. The second one is going to be u to the power half divided by square root of, this is going to be u to the power 3 by 2 minus 2 times u to the power half du. And now we'll use the power rule. So keep the minus sign outside. U to the power half plus 1, which is minus half plus 1, my bad, is going to be half. Dividing by half is same as multiplying by, well, let me just write dividing by half. Same thing here, u to the power 3 by 2 plus 1 is 5 by 2 divided by 5 by 2 minus 2 u to the power 3 by 2 divided by 3 by 2 and then plus c. Now let's put back what u was. The integration is done. We need to resubstitute back. So we get minus, dividing by half is same as multiplying by 2 times, now what is u? U is 1 minus z. So 1 minus z to the power half plus again dividing by 5 by 2 is same as multiplying by 2 by 5. 1 minus z to the power 5 by 2 minus 4 by 3, 1 minus z to the power 3 by 2 plus c. So this is your integral, right? Yeah. Okay. Now note that you can use online computers, like online calculating websites, like there's Wolfram Alpha. If you type this in Wolfram Alpha, it will integrate in both ways. So one is to expand, as I said, we can expand it out and then integrate term by term, or it will also do the substitution rule, right? So you can substitute back and you get the answer. But note that in exam, you do not have access to Wolfram Alpha, so you shouldn't. Okay. So yeah, so please, yeah, so you should be able to do the integrals on your own. All right. So now substitution rule for definite integral is as follows. So if you have integral a to b f of g of x, g prime x dx is going to be g of b to g of a f of u du. So once you do the substitution, you have you notice that the limits of integration have to be changed as well. Okay. So when you're making the substitution u equals to g of x, the interval ab on x-axis becomes a new interval g of a, g of b on u-axis. So this integral, writing a to b f of g of x, g prime of x dx is equal to a to b f of u du is not right? Why is this not correct? Because, well, because now everything is happening in g of a, g of b interval. Okay, so this is a right setup, right? So making substitution, so when you're doing substitution rule, you make the substitution and change the limits of integration at the same time. Okay, so let's look at an example now. Let's look at problem A. So again, in problem A, we say let u be equal to 3t, right? And then we get du by dt is going to be 3, or in other words, you can write du by 3 equals to dt. Now you have to make the substitution already. Okay, so you should do the substitution when t equals to pi, your u equals to what? 3 times that, right? Because u is 3t. So you get u equals to 3 pi. And similarly, when t equals to 2 pi, your u is what? 3 times 2 pi, which is going to be 6 pi. So this integral, let's call this as I. So this integral will convert now. So you can convert everything. So the limits will change. The limits of integral will change. Instead of pi, you will have what? 3 pi. Instead of 2 pi, we'll have 6 pi cosine of u du by 3. So I'll keep that. Well, let's just keep that 3 here. So now what is the integral of this? So 1 by 3 comes out. Integral of cosine u is sine u. And you have to substitute limits of integration 3 pi to 6 pi. This becomes 1 by 3 sine of 6 pi minus sine of 3 pi. And what is that value? That value is equal to 1 by 3 times sine of n pi is what? 0. So 0 minus 0, which is 0. Okay. Now let's look at the next problem. So in next problem, what substitution shall we make? So what is the substitution? Let x be ln u, right? Because the derivative of ln u is 1 over u is there. So then we get dx by du is going to be 1 by u, or we get dx equals to du by u. Now we have to basically make the substitution for, so we have to make substitution for the limits as well. So when t equals to, what is the lower limit? The lower limit is e. So when t equals to e, we get x equals to ln of e. And what is ln of e? 1. Because ln is, after all, log base e. Similarly, when t equals to e square, we get x equals to ln of e square, which is going to be 2 ln e. And what is ln e? 1 again. So this is going to be 2. So let me call this integral as I1. So my integral I1 is going to be, I need to change the limits of integration. So limits of integration is from e square to e. So e to e square. And now that changes from 1 to 2. And the function is ln of u. So instead of ln u, I'll write x. And then dx replaces the du by u. So we get x dx. So this is going to be x cubed by 3, 1 to 2. This is going to be 1 by 3 times 2 cube minus 1 cube, which is going to be 2 cube is 8, 8 minus 1 is 7, 7 over 3. So this is how this integral is done. Now you can check this on Wolfram Alpha again. So whenever you are doing problems at home, you can check it on Wolfram Alpha. But again, note that in exam, you're not allowed to use Wolfram Alpha in any kind of exams. And also, I will have problems where you cannot use online calculator. Yeah, so you need to know the techniques of integration. Okay, so this is how. So on Wolfram Alpha, instead of ln, they write log, but log does not mean log base 10. It means log base e. Okay, there's a difference of notation there. Now note the following. If functions are odd or even, there is an easy way to compute the integral, the definite integral. So recall, what is an odd function? So let's write that down. So f, first of all, the interval, the domain should be from minus a to a. Minus a to r is called odd function. If f of minus x is equal to what? Minus f of x. And similarly, it's called even. So it's called odd if f of minus x equals to, and it's called even function if f of minus x gives you back f of x. Yeah. Now note that odd functions are generalization of odd power, right? Because you know that f of x equals to x cubed is an odd function. And f of x equals to x squared is an even function. However, there are many other functions which do not look like powers of x. Another example is sine of x is odd function. Similarly, cosine x is an even function. Note that there are some functions which are neither odd nor even. For example, f of x equals to x plus x square is neither odd nor even, right? So not all functions are odd or even. Okay. Now, what is the beauty of odd and even function? So odd functions are symmetric around origin. So this means this is how the odd function will look like, the first one. So in this case, the advantage is when you want to compute the integral, suppose you're integrating from minus a to a, this is these are the two areas. So they are exactly same if you have a1, a2. So a1 equals to a2. And in that case, we get what? Integral of minus a to a f of x dx. Since area is a signed area, since the integral is a signed area under the curve, you will get this is a1 minus a2, which is going to be 0. So if you integrate an odd function from minus a to a, that's important, right? If you integrate from minus a to a, you will get 0. Yeah, here. So for odd function minus a to a, f of x dx is 0. Now for even function, so even functions are symmetric in y-axis. So this is how even function will apply. So if you are integrating an even function from minus a to a, this area and this area are exactly the same. a1 is equal to a2, and we get integral minus a to a f of x dx is simply twice this one-sided area. So you can say 0 to a, 2 times of that f of x dx. Now note that you'll say, well, what is the advantage in this case? It helps you to compute the integral in an easy way. Okay. Makes sense? So now this is a pictorial proof of this. You should be able to prove it without the picture. What do I mean by that? So let's prove this without picture, that if f of x is odd function, so f from, so proof, let me write down the proof. If f from a minus a to r is an odd function, then integral minus a to a f of x dx is 0. So let's see the proof of this without the diagram. So we break minus a to a f of x dx can be written as minus a to 0 f of x plus 0 to a of f of x dx. Do you agree that this is a property of integral, right? You start from minus a, take a halt at 0, and then from 0 to a. Now in the second part, I'm going to do a substitution. So what substitution I'm going to do in this integral? Substitute. So take this integral on side, substitute x minus x equals to u, or u equals to minus x, doesn't matter. U equals to minus x. So therefore what will happen, this integral, so the first integral in u equals to minus x in minus a to 0 f of x dx. So we'll call this as, let's call this as I1, and let's call this as I2. Yeah. So this integral, I'm doing the substitution. So how will it look like? So this is going to be integral f of, instead of x, I'll write minus u. Now dx will give me what? So we get what? We get dx equals to minus du. And when x is 0, implies what? Implies u is 0. And x is minus a implies u is minus of minus a, which means u equals to a. So this integral will now change. Where will change from? So instead of a minus a, I will have a. Then on top, I will have 0. Instead of dx, I will have minus du. So I'll have du with a minus sign. All right. So now this will, so this minus sign outside will change the order of integration. We have f of minus u du. So what do we get? Therefore, we get this is, but this f is what kind of function? It's an odd function. So we get what? Minus 0 to a f of u du. So what is this guy? Now note that x is a variable, so I can, u is a variable, so I can change it to, now instead of f I can write, instead of u I can write f of x. So this is same as what? So we get same as minus I2. So therefore we get this integral is going to be minus I2 plus I2, which is going to be 0. So this is a proof of this substitution. When you substitute, so this is a proof that minus a to a f of x dx is 0 when you integrate an odd function. Now similar proof can be done for even function as well. Okay, so this is a proof. Comments. So let's try to look at the following problem. So you notice that right away that this function is an even function. Why is that? If you take f of x equals to 2x to the 4 plus 3x squared plus 4, then f of minus x is going to be 2 times minus x to the power 4 plus 3 times minus x squared plus 4. That is going to be 2x to the 4 plus 3x squared plus 4, which is same as f of x. Therefore, f is an even function. Now, what is the advantage of even function? This integral I becomes 2 times 0 to 3 of f of x, which is 2x to the 4 plus 3x squared plus 4 dx. Now, what is the advantage? The advantage is that the lower limit became 0 and it's easy to substitute. So let's see, this is going to be 2 times, what is the integral of 2x to the 4 is going to be 2x to the 5 over 5 plus 3x cubed by 3 plus 4x, and the limits of integration are 0 to 3. So you put the upper limit, so 2 times, when you put upper limit you get 2 times 3 to the 5 by 5 plus 3 to the power 3 cubed by 3 plus 4 times 3 minus, now when you put the lower limit you get 0, so the whole thing is 0, right? So this is the answer, right? So if you simplify this, what do you get? Anyone? So if you simplify this, is, that is correct, 13362 divided by 5. Now what about the next problem? So again, whenever you see minus e to e or minus a to a, it's a good idea to investigate whether the function is odd or even, right? So now in this case we will break apart, so this is combination of few functions. So note that if you take an odd function, so odd function times odd function equals to even. Similarly, even times even equals to even. This is a function setup, all right? And then we have what? Even times odd function is equal to odd, all right? So these are for functions, not for numbers, okay? For numbers, it is a different story altogether. Yeah. So now note that what kind of functions are these? So e to the minus u square. What kind of function is this? Odd or even? So even, odd. So this function is even, that's right. What about sine u? So sine u is odd, we already saw. So sine u is odd. And then what is the remaining one? 1 upon u square plus 10. What is that function? Is even. Perfect. So now when you multiply all this function, we get what? So f of x or f of u is going to be is what kind of function? Is an, so you multiply two even functions, you get, sorry, you multiply two odd functions, you get even function, right? So you multiply, sorry, nobody corrected me. 1 by u squared, that's right, thank you. 1 by u squared plus 10, I mistakenly marked it as odd. It's not odd, it's even, right? So when you multiply two even functions, you get even function. And then when you multiply with an odd function, you get an odd function. So this is an odd function. Now note that instead of doing this, you could have directly checked out that f of minus u is minus f of u. Okay, that could have been done as well. So this is an odd function on minus e to e. Therefore, integral minus e to e f of u du is what? 0. So you see, in odd function, the computation becomes super easy. Why is that? Because that integral turns out to be 0. In general, if you're given minus a to a, you can break it into some parts, some odd part and even part. So this helps you with computation of the integral.